a couple housekeeping items. If you have any questions, feel free to comment on the right-hand side of the of YouTube, and we will see those comments and we'll moderate those. And what we're going to do is we're going to do a Q&A section at the end with everyone. So feel free to ask questions. We'll try to answer those as soon as we can. The way this presentation is going to go is Erika has a presentation with some slides. Then she's going to do some live coding live with all of you on the line. So we're very excited about that. And then we'll do questions and answers, and we'll try to stay on as long as we can to get everyone's questions answered. And if you're interested in getting these slides after the fact, just check back with our YouTube page. We're going to add the slides in the description. So don't worry about that. You'll have access to those. So with that, I'm going to turn it over to Erika. Erika, welcome. We're super excited to have you, and can't wait to learn more about automating server setup with Ansible.
Hello, everybody. It's a pleasure to be here today. Thanks for coming and joining us. So just a little bit about me. I'm a DevOps technical writer. I'm very into Linux and open source. And my background is in systems administration and PHP development. And I've been working with Ansible years. I'm very enthusiastic. I've worked on some open source projects about Ansible, related to Ansible. And also wrote a ton of tutorials about it. And you can find me on Twitter. I'm Erika Heidi there. So let's set up some goals, some expectations about the workshop today, this webinar. We will start by revisiting some configuration management concepts. Then we will get familiar with Ansible, some terms and how it works. Then we will learn about Adhoc Commons. And then we will go through Playbooks. So we'll talk also about some advanced topics. And then at the end, we will run a playbook to deploy a demo PHP application, a Laravel application. So the way it works, as Tim explained, I'm going to present the content first, then we will go to the live demo at the end. So when you're going to run these by yourself, you will need some prerequisites. You will need a control node with Ansible installed. And you will need at least one Ubuntu server to serve as managed nodes. And then there is this repository that you can clone to get the content, the provisioning scripts, and the Laravel demo application. So you will have access to these slides at the end. You can do everything. So let's start. We have a lot to cover today. So we start with configuration management. So what is configuration management? So in a nutshell, configuration management is a way to handle system changes in a way that it keeps integrity over time. So it's a term that comes from other industries, but in server configuration management, we are talking about maintaining server integrity over time and finding ways to automate setting up servers and making sure they reach a certain state. So there are many tools like Puppet, Chef, Ansible, Salt. These are just some of these tools. They all have different architectures, different ways to work with automation and configuration management, but the goal is always the same, is to automate infrastructure in a way that is repeatable and consistent. So you can do it many times and you will reach a certain state at the end, the same state. And the benefits of configuration management, these are some of the benefits. So the first thing is that you will have your infrastructure set up as code. So this brings a lot of different benefits, the same way as you have with code. Like you can have a repository with your infrastructure set up. So your provisioning scripts will be in a repository so you can keep track of any changes. It's easier to share with other people as well. And this will also streamline the provisioning of new servers. If there is a problem with a server, you can quickly recover from critical errors. So you can dispose of a server and create a new one as needed. And you can go from development to production with minimal changes. Maybe you can use Vagrant, for instance, as a local development environment, using Ansible to set up this environment, and it will be the same as a remote environment. You can use the same provisioning scripts, just changing a few variables, a few details. You can also, maybe you don't use Vagrant on your local development environment, but then you may have a testing environment and a staging environment and production environment, and you want to make sure that all these have the same setup, exactly the same. So using a configuration management tool will help with that. And what is the challenge? Why is not everybody using it? The main challenge is the learning curve. So each tool will have different learning curves. So some are more difficult to learn, and they all have some specific syntax. And it's like learning a programming language, but it's the scope is reduced. It's not so complex as a whole new programming language, but in many ways it is similar to that. So that is when Ansible comes, because Ansible was created and was always meant to be simple. When in the beginning, the slogan was something like automation made for humans, because it is human readable. It's easy to read the scripts. It's not difficult to understand what is going on. Some of the Ansible characteristics. It is Python based. It has an agentless nature. Uses only SSH. So this is one of the main differences from Ansible to other tools like Chef and Puppet, because you don't need to install any agent on the servers that you want to control. You only need to install the control node, and you can use Ansible and manage the remote servers over SSH. As long as you have an SSH connection to those servers, you can use Ansible. It has an idempotent behavior. This is common from most, probably all configuration management tools. That means you can run the script, the provisioning multiple times, and you will reach the same result at the end. It uses YML files to define the automation. So it's a language that is known to most developers know YML. It's common and it's human readable. It uses a sequential execution of tasks, which is not the case in Puppet, for instance, where you have to explicitly declare dependencies between tasks. In the case of Ansible, what you see is what you get. It is said to be batteries included because it contains hundreds of built-in modules. So probably what you want to do to automate something on your server, probably there is a module for that. Sometimes you need to install a prerequisite, a package, but you will have a module, for instance, MySQL module, user module to manage users, Kubernetes module, Docker module, and so on. Even Composer, PHP Composer, there is a module for that. It uses Jinja 2 as templating system, so you can benefit from having variables like a configuration file, for instance, an nginx configuration file, and you can set up variables to make it customizable. And it can be extended in any programming language that is able to return JSON. So you can create modules and you can create dynamic inventories, even in PHP, for instance, that I've done that before, and you can return a JSON and it will work. Let's talk about some terminology. This is important. Control node. So the control node is the machine where Ansible is installed. So it can be your local machine or it can be a remote server. It just cannot be a Windows machine. Sorry about that, but Ansible needs to be installed on a Linux or a Mac OS server. And if you are dealing only with your personal projects, for instance, you are the only person who are managing these servers, your servers, then it's okay to use your development working machine. But if there are many colleagues using these to deploy servers, to set up servers and deploy applications, then it's better to use a dedicated server for that, an Ansible control node server. Then you have manage nodes. So these are the hosts that you manage with Ansible. And these nodes will be listed on an inventory file. Modules, I talked about briefly before. So modules are sort of a package to help you keep something. So you have an apt module, is to install packages on Debian-based systems. You have the MySQL module to set up MySQL databases. And you can have also QSOM modules that you can create. A task is like the minimal unit of action to execute on a server. Handlers are used to manage services, like to restart the web server or any other service. Playbooks are a collection of tasks and some other artifacts like variables, definitions of variables. So you can also include other playbooks from a playbook. So it's kind of a class, let's say, if it was a programming language. And a role is a kind of a package. So you have a defined predefined structure that Ansible knows where to find variables, where to find templates and files and playbooks. So it's all organized in a certain way to facilitate sharing and breaking down your setup into smaller units that you can reuse. So we talked briefly about Ansible, configuration management, and now how do we connect to nodes? This is what we're going to see now. The first thing we need is to set up an inventory file. So this is where your hosts are listed. The inventory file is typically in INI format, but there are other formats that are supported as well. So you can group servers and create groups and subgroups. You can just list also if you can create a very simple inventory file with just a list of IP addresses for your servers. And you can also create additional connection parameters and set up variables. Let's see an example. So this is an example of an inventory that has 3 groups. So it's actually 2 groups and 1 subgroup. So we have a development group with 1 server and a production group with another server. And then we have a subgroup called servers. So it's a children group composed by development and production. And at the end, we have all. The keyword all means all. So all servers on your inventory. And we are defining that, setting a variable for all servers. So this is going to be valid for everything, all the servers in your inventory. We are defining, telling Ansible to use Python 3 as Python interpreter, because for backwards compatibility reasons, Ansible defaults to Python 2, but we want to use Python 3. Okay, so let's go. Then once you have your inventory set up, you want to test connectivity. So you can use a command for that, an Adhoc Commons. And this is the ping module. The only thing it does is, like the name says, it pings the server. And you can use it to test if you have proper SSH connection to the server and to test if your managed server, your managed node, is able to execute Python commands. So these are the 2 things you need in order to run Ansible on the remote server. Some additional connection settings that you might need to use. You can specify the user. You can specify a QSOM SSH key. You can also provide a sudo password. And if you are using password-based authentication, you can use this option. So it's not, overall, it's not recommended to use password-based authentication, but in some cases, when you create a new server, you have only a root account with a password, so you might need that for an initial setup, setup script, provisioning script. So you might need that. So let's see a bit more about Adhoc Commons. The ping module, running the ping module, like we showed before, it's exactly this. It's an Adhoc command. And why is it useful? Why not using just playbooks? Well, Adhoc Commons are useful for tests that you don't want to repeat. You don't need to repeat with frequency. Sometimes you might want to reboot a server, you might want to restart a service, or copy a file, use a module to copy a file, do an rsync, or check the status of a service, install a missing package, or add a user, for instance. And it's just like we did before. So we will use the Ansible command. And in this case, we are saying that we want to execute this on all servers from our inventory. We are using a custom inventory file, -i inventory, and -n setup. So this is another module. We used the ping module before, now we are using the setup module. The setup module is used to obtain information about the server. This is called facts. So facts are information like IP addresses, network interfaces, operating system, and a lot of information you can get. And this will be returned as a JSON content, and you can have access to these variables from your playbook. And this is very useful. Sometimes you might want to customize a playbook depending on the operating system, or you want to set up some network related thing, configuration file, and you need the IP address, and then you can use facts for that you can obtain with the setup module. This is another example of running an Adhoc command. This time we are running a bash command. So -a here is for arguments. When you don't specify the -m, it is by default, it will use the bash module to run commands. So in this case, I'm running UFW status to check the status of the firewall. And then this is how it looks like, the return. These are other options that you can use to connect and run Adhoc commands. So you don't need to run everything on all servers. You can specify one of the servers or a group, for instance. So the first is an example of running a uname -a. And you can also, this is the second argument, the second example uses a module apt, the apt module, to install a package. Also, if you don't want to run, you don't only want to check what is going to happen if you run that command, you can use the ---- check option. So this will only show what would happen if you were to run these commands. And if you need more verbosity, you can adjust this with -v, from V to VVVV. So this will vary the level of verbosity. And with 4 Vs, you'll get details of the SSH connection, which can be very useful if you are running into connection problems. Okay, so now we're starting to get to the good part. The Ansible, the Adhoc Commons, all that stuff is more to get you used to it. Test connection, see if everything is right before you can run a playbook. Let's have an overview of playbooks now. A playbook can target single servers or groups of servers. So remember when we were setting up the inventory file, we have a development and a production group, but we could also have a web servers group and a database servers group, or any groups you would like. So you could create a playbook and specify that you want to run only on database servers. You can also limit the execution during execution time. When you run the playbook, then you can limit the execution. It's usually we will say that we want to execute on all hosts, and then we'll filter or limit the execution when we run the playbook. We're going to see that. So a playbook, the difference from like running an ad hoc, because you could install a package or do something via an ad hoc command. But of course, playbooks are the real deal because you can automate a series of tasks and reach what you really want on a server. And you can use a lot of features for that. You can use variables. These variables can be on the playbook or can be included from external variable files. You can use facts, talked about that earlier, to get information like the IP address of the server. You can use loops. You can use tags to tag the tasks and only execute what you want, or then skip some tasks. You can use conditionals. You can use blocks, like conditionals with a block. It's useful because then you can test for a conditional. A condition like if something is not installed already, then you execute this block, and then a block of tasks comes. You can include task files. So to better organize, you say you will have a big playbook. You can break it down in different playbooks and include them from a single entry point. And you can use roles to organize everything even more. So this is an example of a very simple playbook. It's a YML file, so it starts with this YML notation. And then each playbook can contain a series of plays. So this content you see is a play. You could also have another play at the end, at the bottom. So I start with hosts all. It's telling Ansible that I want to execute this on all hosts from my inventory file. Become true is a privilege escalation option parameter. It's like setting sudo. It's the same as sudo, but like this is independent from system. This is more independent. So we have vars. The vars section is for setting up variables, and we have the tasks section to define the tasks, the actual tasks from the playbook. And so we define a variable called sys packages, and this is actually an array or a dictionary. And we have a task. We set up a name for the task, install packages. This will show up in the output. And then we use the apt module to install the packages. So the way it works is when you, instead of passing a single name, a single package name to this task, I'm passing a dictionary, an array. So this will make Ansible loop through the task, and it will run the task to install Vim, then Git, then curl. So this is basically how loops work in Ansible. I'm also telling the apt module to update the cache first. So this is like running apt cache update. And I'm telling Ansible to set up the packages to install the latest version of these packages. This is also something that you can customize. This short video shows how it happens, how the execution happens. We'll have a demo at the end, but this is just to show the same playbook that we saw in the previous slide, the execution. So first it will, you see that says play all, it's executing on all hosts. And then we have test, gathering facts. The first step on playbooks is to gather facts. It will collect all facts from all the systems. So you can use them on the playbook if you need. You can also skip this if you want it to go faster. The second task is going to install the packages. So the installation, the package installation, it always takes a bit longer. Of course, it will run also the apt cache update before, and then you can see that it shows change. So some tasks will show okay, so nothing changed on the server. And when something changes, a state changes, then it will say changed. And this was executed on 2 servers in parallel. And then at the end, you have a recap of what happened, how many servers changed, how many tests were okay or changed. These are a few extra options. Oops, what happened? Sorry, this thing. Yes, extra options for playbooks. If you don't want to run the playbook, you just want to list the tasks or list the hosts or the tags that are included in the playbook, you can use these options: list tasks, list hosts, and list tags. You can also use the verbosity options. The same verbosity options for the commands are valid here. The same connection options are also valid here, the extra connection options. And if you want to control the playbook execution, you can execute just a number of tasks. For instance, you can execute just tasks that are tagged as nginx and MySQL in this example, or you can start from a specific task, and you can also skip tasks altogether, skip tags. So all tasks that are tagged as MySQL will be skipped in the last example. All right, so we saw how to run a basic playbook, how it looks like. And now I would like to talk a little bit about a few advanced topics. And this is kind of a requirement for the playbooks that we are going to run to set up the length server and deploy Laravel application at the end. The first thing I want to talk about is group variables and multi-staging environments. So group variables, they are very useful to support multiple environments. So you want to have like the very same environment, but with different, just a few different settings, different credentials, for instance, is a common thing. You want to have like a testing environment to replicate what happens in production with just a few differences. So you can use the very same provisioning scripts, the very same playbooks, only with a few different details, a few different variables. And the group vars directory is reserved for variable files that are automatically loaded during playbook execution. So the way it works is you will have a default value set up in a file called all.yml. This is going to be inside your group vars. And when Ansible runs, it will always load this file, all the variables that are in the all.yml. And then you will set up a few per environment values. And then these will go into files that are named after the group that you're going to target. So let's see an example. You have an inventory on the left. You have a development group and a production group. Let's say the development is a local internal private IP virtual machine with Vagrant. And then you have a remote production server. So in the all.yml, the default values, you have a few like just local development values. Remote user, MySQL root, server root, and document root. These are the values that I need to run my playbook. And then I will create a different file now, only for the production server. And I don't need to set up to override all these variables. I only need to override the variables that need to be. So I'm gonna override remote user, MySQL root, and server host, because these need to be different. But the document root is the same. I don't need to change that. And Ansible will load this as default value. Okay, this was the first thing. Now, you might have thought like, well, if I have these important values credentials on my production, it's very easy to find out that those values, like my MySQL root password or something, credentials and all. So how am I going to share these, right? So Ansible Vault is used to protect sensitive data. In this case, we can use Ansible Vault. Files with sensitive data can be encrypted with Ansible Vault. So there are a few different commands, but basically what you're going to do is you set up your production variable file with your all important credentials, and then you will run an Ansible Vault encrypt command. And then Ansible will ask you for a password. You will provide a password, and then the file will be encrypted and nobody can see the actual credentials. So you can even share on your GitHub or something. And then you will need to provide this password when you are running a playbook, or if you want to view the file, check the credentials, or edit the file. Of course, you are going to need to provide the password. And this is the recommended approach to set up production variable files that contains passwords, keys, etc. And a password can be provided not only by prompt, which is the default, but also by a script output or a text file. A text file is not a very good choice, but you can create a script that provides an output to obtain these passwords from somewhere and then provide to Ansible. This little video shows an example of Ansible Vault in action. So first we have the production file with all plain passwords and important passwords, all in plain text. And then we are going to run Ansible Vault here. So it's going to run, ask for a password, you confirm the password, and then now if you check the file again, it's all like this. So it's all encrypted. And then when you are going to run again, every time you're going to run the playbook, you have to provide that password. You have to provide an extra option when running the playbook, ---- ask vault pass. These are the commands that you can use with Ansible Vault. To create a new file from scratch, already encrypted, you can use Ansible Vault create. And to encrypt an existing file, Ansible Vault encrypt. To just view the file contents, you can use Ansible Vault view. To edit a file, you can use Ansible Vault edit. And to permanently decrypt and put it back to plain text, you can use decrypt. And that was Ansible Vault. Now, finally, before we can go and run the demos, we need to check out roles. What is role, how it looks like, how can I do it? Roles provide a structured way to organize your tasks, templates, and other files. I talked already about that, right? It facilitates reusing and repurposing common automation procedures by separating a long playbook into smaller chunks. So, for instance, instead of having a one playbook with all lamps set up, you can break down into nginx, installing nginx, installing MySQL, installing PHP. The benefit of using it, other than making it easier to share this, is because Ansible will already know where to find variables, tasks, handlers, and other files, and the playbook will look a lot cleaner. You can find a lot of roles, user-contributed roles on Ansible Galaxy, not only roles, but modules and other things. It's a good resource to check out for something. Sometimes you want to install something complex, then you don't want to go to the trouble of creating the playbook yourself, creating the role yourself, then you might check out on Ansible Galaxy. You might find it there. This is an example of a simple nginx role. So this is the directory structure on the left. You will have will create you need a directory called roles, where your roles are. So this is like the default. Ansible will look for a directory called roles. And then we have the role name as the role directory. And inside the roles nginx, I will have defaults. So this directory is supposed to contain default variables. So the main YML file inside the defaults will contain default variables, but this is like the lesser precedence of variables. So any other variable with the same name will overwrite this. This is just like if the person forgets to set up a variable, then you have this default value there that the playbook can use, but they can easily overwrite that on the playbook itself. Handlers contains the handlers to manage the services. Tasks contain the tasks, and templates contains the templates. The only actual mandatory directory here is tasks. So you will need a tasks directory with a main.yml file inside it. That is the only mandatory structure you need for a role. Because Ansible will load this main.yml file from the tasks directory. And on the right, this is how your playbook will look like when you use roles. So it's going to be a lot simpler. And the tasks file it doesn't need to have the hosts. It won't have any of this. It will just have a list of tasks. So it's easier to read and understand everything. Okay, so we have seen all the prerequisites necessary to go to the actual fun part, the demo. First, we're going to just have a look at the files because it's easier to show here than on a terminal. So we have our length playbook. So we have two different playbooks in this setup. We have a length playbook and we have a Laravel deploy playbook. The length playbook is using roles. These are simplified roles. It's not from Ansible Galaxy. It's roles that you can read and understand and very focused on Ubuntu 18.04. So we have a few different roles. Initial server setup, it will create a system user with sudo privileges and install some basic system packages and enable UFW, the firewall. So this is like the initial server setup that we have in our tutorials, in our community. We have a MariaDB role to install MariaDB, set up an application database and user for the Laravel application. We have a PHP role that will install PHP FPM and some required PHP modules that are required by Laravel. And we have an nginx role to install and set up nginx. This will also enable port 80 within the firewall. And then we have a composer role that will install composer globally. So this is our length playbook. And this is how it looks like. So we set up it to run in all hosts from our inventory, to use sudo for all tests by default. And so we set up some tags here. The difference here from the example I showed before is that I set up some tags. So if something goes wrong during the playbook execution, you can run it again only from starting from a specific task, a specific role actually. So you can use the tags to control the execution of this playbook. And then we go to the Laravel deployment playbook. And then I will show all the tasks in detail. What we need to do to deploy Laravel application. Let's go by parts. So first, we need to create an application document root on the remote server. Then we need to synchronize the application folder on the remote server. You could also use Git to clone a repository, but that doesn't work for all applications. It's usually a better practice to clone locally or only on deployment server and then send the files to the production server. Then we are going to use the ACL module to set special permissions for the www data user on the storage folder, because we need permissions for our sudo user, and we also need permissions for the www data, because this user will create files like cache files, logs, and things like that. Then we need to set up an .env file, which is a configuration file required by Laravel. It is going to be based on a template. Then we are going to install the dependencies, running composer install. We'll generate an application security key, and we'll set up a public link for a storage folder, and we'll run the database migrations and seeders. These three final steps, they are all Laravel specific. So this is going to run the artisan command to run these final tasks. Let's see each task in detail. Some of these are simplified because they would not fit well in the slide. Just removed some variables, but it's nothing, it's very similar to what you will find on the repository. So first, we will make sure that the remote application document root exists. So I'm going to use var www travel list demo. The name of the application is travel list. And I'm going to set up, I'm defining that this is a directory, and I want this mode 0755. And then I want to set up it as the remote user is the owner and the group of this directory. So this remote user is a sudo user that we are going to create in the initial server setup that we saw before in the other playbook. I'm going to use this because then the remote user, the sudo user, is the responsible for running the commands, the Laravel commands afterward. You shouldn't run as root, and you should also not run, shouldn't use www data to run the Laravel commands, the artisan commands. Then we will use the rsync module, the synchronize module actually, that uses rsync to synchronize the application files. So this will synchronize my local application folder to the remote document root. I have the synchronize module, I have an SRC, a source, and a destination. The synchronize module has a few other options that you can set, like to ignore some files, and you will find this on the actual playbook, but it will be too long here. So I stripped those to simplify, but this is basically it. The ACL module uses setfacl, it's a Linux command, to set up additional permissions for the directories. So we want to make sure that the www data user also has writing permissions, writing and execution permissions on the storage folder. This is where the logs and cache files are generated. We are going to set an env file for Laravel, and then we are using the template module for that. So the template module is quite simple. You set a source, a local template, and then you set the destination where the template is going to be created. The file is going to be created. Then we are going to install dependencies with Composer. So this is going to use the Composer module. And notice that I say become false. So I don't want to run this as root. I cannot run this as root. It's not a good idea. So this is going to run Composer as the sudo user. Composer command install, and then the working directory. And I set up some tags because sometimes you might want to run this again. You might want to run this playbook again, but just a few tasks on it, like Composer install. You might want to update some packages, and you might want to do that. And this is going to use the artisan commands to execute, to generate the key, security key that is required by Laravel. So these are the final tasks. set up the app storage link. So you can see that this is a command. This is a raw command. You can execute any command like that. So you just pass the full command that you want to execute, and this is how we do for the artisan commands. Set up the storage link, and then run migrations and database seeders. Okay, so now we can move on to the actual demo. And this is how it's gonna work. First, I'm gonna do everything from scratch, sort of. I have the playbooks here, the content from the repository, but I'm gonna create now the new nodes. And then we're gonna test it using Ansible Adhoc Commons, and then we're gonna run the initial server setup playbook, and then we're gonna run the Laravel deploy playbook. So let's go. Before, first thing is, I'm gonna share this tab here. So we are gonna create a couple droplets. And I wanted to make sure to show this because it's important to have a proper SSH connection, and we can, and in this case, I have a key set up for I have a Ansible control node as a server, a separate server that I call Stargate, of course. And then I have a special key that is only on that server, and then I'm going to create these nodes now, and they will only be accessible from that server, from the Ansible server. Like this, let's say Laravel demo. So I have two. I have my key here added, and boom, let's create it. So the next thing is set up the inventory file. I'm going to copy the IP addresses here, and I'm going to create an inventory now. So let's share my terminal now. Okay. So here I have an inventory example that looks like the one I showed you before on the slides. I'm gonna copy this. Just call it host, because just to make it shorter. I'm gonna copy the IP addresses. Just a moment. And the second one, okay. Okay, so we have an inventory file. Oops, not this. We have an inventory file here set up. So now we can run an Ansible test, an Ansible ping module. Ansible all. I like to do like this. First, yes. So then the command I want to run is ping, and in this case I need to connect as root because this is the only user available now, and it has my SSH key. Oops, yes. So the first time you connect is like just the normal SSH thing. Let me clear this and do it again. Okay, so success. So this means I am good to go. I can run commands, I can run playbooks. So another example of an ad hoc command. Oops. Let me clear this. would be your name. Let's see. So you can see the system information of each node. So now we can run a playbook. So I'm going to run the server setup first. Okay. To keep things simple, I'm not going to use Ansible Vault and all this stuff. Otherwise, it's going to take too long. I'm just going to run it now. So to run a playbook, it's Ansible Playbook. Hosts, and have it set up, and then I need to run as root now, but I'm creating a user, call it Semi, which is the same user I'm using here on the control node. So I won't need to provide a user anymore, because in the next time I run a playbook, because this remote user we have the authorized SSH key, the same key that I'm using here. So the first thing is gathering facts, then we installing prerequisites, some packages, then we create a wheel group. So these are some things we need to do to create a passwordless sudo user that I'm gonna use in the next executions, the next playbook executions. Then I disable password authentication for the root user, the security measure. Then I update the apt and install some required packages. Then I will enable the firewall. And now I am installing, so this was the initial server setup role. Now I'm on to you see the setup role here. So now I'm on the MariaDB role here. So it installed prerequisites, set up the root password, removes all anonymous user accounts, removes the MySQL test database. So this is some security measures. And then now I am here in this task creating the application database, and then creating the MySQL user, main page. Okay, so now we are on the PHP role now. Install main PHP packages. So these are going to be required. And then PHP modules that are required by Laravel. You can see the detailed output for each server. Then we are on to the nginx role, installing nginx, installing. So here, this is something very interesting. This is a test. So it says fail, but it's actually on purpose. So what I did was I created a variable to get the output from this command. And I check if it comes with error. If it comes with error, then it means Composer is not installed yet. So I need to install Composer. And this is a conditional thing. And it's ignoring. So you have to, when you do this kind of stuff, you have to use ignore errors, additional parameter on the task. So because otherwise it will just stop the execution altogether. So now downloads Composer, run Composer installer, copy, and such and such. So Composer, at the end, Composer is installed, remove installation script, and finally, this. So this is the handler being executed. So an interesting fact about handlers. Handlers are almost the same as tasks. So they are only executed at the end of a play, typically, unless you force the execution. And this is for performance reasons. And many times you don't need to, most of the times you don't need to restart a service more than once. You only need to restart at the end. So this is how handlers work. So, okay, here we have a LAMP server. So if you go to the browser right now, this then I will have a default nginx page. So you can try that. Let me share my tab again. I will share maybe this tab here. Okay, so this is because the PHP, there is nothing on the document root actually right now, so it says file not found, of course. So let's run the second playbook now, which is where we set up Laravel. Well, the server is there, it's working. Now let's go to the terminal again. Okay, so now we are going to run the Laravel deploy playbook. So you can see these are all the tasks that we've seen on the slides. Some just a bit more longer because there is a lot of variables and full path to the PHP executable, which is more recommended than using just PHP. And then we can just run this again, like use the same, but we have to change this, of course. Laravel deploy. And now we don't need to provide a user anymore because I set up the initial server setup play role, created a new user with the same name as my local user and using my key as authorized key, so I can connect directly to this server, to both servers this way. So let's run it. Creates the direct directory. Our sync files is pretty fast, as you can see. And the good thing is that they run in parallel, so it doesn't change much if you have 2 or 3 or 4 or 10 servers, because it all runs in parallel. So Composer install, of course, is what takes longer in this thing. You can see all the things that we've seen on the slide. So our sync application, set up additional directory permissions. There's also this bootstrap cache folder that needs the same additional permissions. This wasn't on the slides, but this is also necessary. Then we set up the .env file. This file, you will see if you get to the repository, you'll see that it uses a lot of variables to set up the MySQL user, MySQL database, and this is all on the group variables. This is all set up on the group variables. And then we are here on the install Composer. It shouldn't take longer. Yes. Oh, this was one. One is okay. Then okay. So the next tasks are going to run fast. Once Composer is installed, all the dependencies are installed. Then it generates the application key. It will set up the storage link. So this is a link, public link to the storage folder, and then it will run the migrations and to set up the Laravel database. So now let's go and see this. It should be live. Yay! So this is the Travelist demo Laravel application. It's, yeah, this is semi in various places. And the other server, can check it's true. So in real life, you would have it will be a staging or a testing environment in the production environment. So yeah, that's it. We are done. I would like to share again. Okay.
Yeah, let's. We had some questions,
Okay.
Erika. Do you want to go? You want to go through them? Okay, cool.
Yeah, I can create. Yeah.
I'll post them here, and we can go through them.
Sure. Can Ansible also help with Docker clusters? Yes. So Ansible has modules to set up Docker, and also Kubernetes modules. So you can use these modules to set up both Kubernetes and like only just Docker. If you want to set up containers, you can use the Docker modules for that. So I just created .ini file anywhere. For the inventory file, yes. The inventory file, it doesn't need to have a .ini extension. Actually, it just, you can use, so a question that came up in the last time I presented is, should I have a single inventory file or multiple inventory files? And I recommend having per project inventory files if you have many projects, unless you have just a few servers. But if you have multiple projects, then it's better to have separate inventory files per project, and the inventory files can be on the repository of the project or not. You choose. Because if you have only, there is a default inventory file on etc Ansible hosts, but then it's a bit dangerous, I think. I already run by mistake, like set up a lame server on a server that shouldn't be a lame server, or things like that can happen. So it is more safe, it's safer to just have per project inventories. And yeah, you can have as many as you want. Is there any support for something like encrypting a file so that only one of a group or YubiKeys hardware USB cards can decrypt it? Well, I think so. Well, this is a bit complex, but I think because you can create a script to provide the password. So you might be able to, if there is not one already, you can probably create one script to read these YubiKeys, hardware, something, and then provide it to Ansible. What does it mean with sudo but independent? I don't think I quite understood the question. But like, I think I understand now. Okay, so before, few years ago, the privilege escalation parameter would be sudo. So in the playbook, you would say sudo, yes. But to extend compatibility with other systems, with Windows servers, because Ansible can't be installed as a control node on Windows, but it can control Windows servers and all sorts of operating systems. So to make it independent, to make it support any privilege escalation system that can be used in the future, they changed it from sudo to become. So it's become. This is definitely making me more scared and more willing to use Ansible. Okay, nice.
Not a question. Yeah, not a question. I just thought I would end with a bit of positivity that came in. So thanks, Michael. I think Erika. I think Erika, that speaks very well to your presentation abilities. That we've had some converts. So that was all of the questions. So we're going to do two things now. We're going to post Erika's Twitter handle here. So if you have questions, you can connect with her on Twitter. And then the second thing is just to remind you to check out our YouTube channel after the fact, because we'll post a recording of this, and we'll include links to the slide deck and the GitHub repo, sort of any links that Erika brought up. We'll make sure those are included. And we also have this workshop published on our community site as a tutorial. So watch for the chat. We'll post that here as well. And Erika, is there any last words of advice for anyone that attended today?
Just that if you can check our community tutorials, there are a bunch of Ansible tutorials there and to get started, and the workshop kit that is that has the slides and everything from this webinar also has some links, so to get everything set up and run this demo, this exact same demo, you can do that.
Great. And again, we just included Erika's Twitter handle and then the link to the workshop. So thanks everyone for attending. Great questions. We really enjoyed doing this. And thank you so much, Erika. This was amazing.
Thank you.
We really appreciate it. Okay. Bye, everyone. We hope wherever you are, you're staying safe. And we'll be back with more content down the line. Thanks, everyone.
Bye.
Bye.